A 12 Newton force is applied to a rope connected to a 8 kg block resting on a frictionless surface. So what we have here is we have a frictionless surface. We have a 12 Newton force applied onto a rope connected to a 8 kg block. So we have a 8 kg block and the rope is this, and the rope weighs 0.6 kg itself. You have a force of 12 Newton. What is the force exerted by the block on the rope? Wait, what? If the rope weighs, okay, 12 Newton applied to the rope connected to a 8 kg block resting on a frictionless surface. If the rope is this, what is the force exerted by the block on the rope? Okay. So basically the tension force in the left direction. Right? The rope pulls the block to the right and the block pulls the rope to the left. So basically we have to find the tension force at this point. So how do we do this? It's just a single commonsensical point and you guys are done. If not, it's the same traditional question. So I'm going to paste the same thing. Now I'm not what I'm going to do is I'm going to do this. And now this two will be massless. You need not do it in your exam. If you understand the concept, you are done basically. So this is for your understanding basically as of now. What did I do? I considered the new rope to be massless and in place of that I'm replacing with a block which is 0.6 kg. Now you guys know what to do. Right? So the same thing. The system's acceleration. Whenever you have to find anything, you need to know the acceleration, especially with such question, that is. So acceleration of the system is given by force by the mass, and that would be, this is your force on system by total mass of system. So this would be 12 divided by 8.6 and this is equal to 1.34, sorry, 1.4 meter per second square. Now, this, if I call it as T1, okay, so from T1's perspective, right, T1's perspective, where T1 is the tension with which 8 kg block is pulled. Right? So from T1's perspective, it's just pulling 8 kg with an acceleration of how much? 1.4 meter per second square. So basically, therefore, T1 is equal to, what is that? 8 times of 1.4, 11.2 Newton. So 0.8 Newton is used to pull the mass. What is the force exerted by the block on the rope? From here, we can imply that the force exerted by the block on the rope is 11.2 Newton's third law, to the left actually. So let me write that. To the left or opposite. What is it? Have we taken left and right? No. Since we're not talking about left and right over here, opposite to T1's direction. That's my reference, T1's direction. The diagram is the reference. So yeah, that's your answer. If not, you will lose marks, guys. If you don't write that last statement, then you're technically wrong. You're not yet reached the goal. It's that.